Okay, so what we have done till now? Some different numericals. Okay, so today we'll start something. Let's see any other question like that.
So we've completed the entire chapter, right?
Yeah, that's what I was thinking.
So can we start with magnetism, because we have already completed this chapter in college.
So next chapter will be magnetism. Yes.
Can we start it today, because we already did TPPs on this chapter, the first 3 chapters.
Oh, okay.
So we can start the new chapter, right?
Yeah. Then we can start with a new chapter here. So okay, so next highest portion, that is geometric optics or magnetism. So we'll start with magnetism.
So what are the important chapters in grade 11 portion, with the highest
So from the
weightage?
11th portion, see, highest, kinematics is fixed thing, but it's not writing. Yeah, iron is fixed. Okay, and projectile, in that there will be one question for projectile.
Okay, so motion in 1D and 2D.
Yes, and this circular motion means those system of particles and center of mass and all that.
Rotation.
Yes. So that will be one question, definitely. Thermodynamics, one question, definitely. But one more thing, there is oscillation. Yes, oscillation and wave. So these are highlighted topic. These are definite question part. And next thing comes with the not gravitation. Yes, mechanics of solids and mechanical properties of solids and fluid. That will be one definite one question. So these are main important first priority question. So we'll start with magnetism now. Let's go. So you're okay with all the questions, right?
Yes,
no
sir.
problem in that current electricity?
No, sir.
Okay, then. Fine. So for starting magnetism, first of all, what is magnet? What is magnet?
It is something that produces magnetic field or has north and south pole.
Yeah, or attract something like a magnetic material, which is iron, cobalt, or any other nickel. So these are the things which attract. That substance is called magnet. Okay. So there are two types of magnet, one natural, one artificial. One second, please. Uh, sorry, like, yeah. So it is what magnets are like two types. One is artificial, one is natural. Natural or artificial. So natural comes from like a magnetite and all that, right? Magnetite,
Yeah,
you studied in sixth standard. Magnetite Fe2O3. I guess it is right. Okay, artificial, which is like man-made, which are making like all this electromagnet and all that. Those are artificial. So our study is all about artificial. It's not anything about like natural. So artificial, we have like some properties like attractive, repulsive. So and then orientation also like how it is placed vertically or like that. So let's discuss all that small thing first. Let's discuss this all basic thing. Okay. So if we take a length of a magnet that is L, like that is geometrical length. Okay, this one, geometrical length, and south to north, this pole distance will be taken as 2L. Now this is for pole distance. Okay, this is for pole distance. Now this distance only will consider for dipole moment. If you remember dipole moment from the first chapter, similar type. So only this distance will consider for the pole, not like geometrical length, not exact length actually. It's pole to pole, south to north pole. See, this might be possibility that they might be equal. Okay, but we will consider 2L. So magnetic length is 2L and geometric length is L. Even if we consider like circular path, same way another circle. In that, what will be considered here? R. Diameter. So that is 2R here. So this also like from this point to this point means south to north. Let it be horseshoe magnet or bar magnet, whatever it is. Now, generally, this all are almost equal. If in case they're not equal, but then calculation will be like magnetic length equals to 5/6 of geometric length. So this conversion is a bit almost one. It's almost one. Not exactly, but almost one. Next is your like what we have discussed here, pole distance, and let's see. We'll say pole strength. Pole strength means are you there, Aditi?
yes, sir. Can you hear me?
No, I didn't.
Just a minute. I'll just connect the Bluetooth.
Okay, so what is pole strength?
Magnetic, the ability of attracting something, things towards itself. That's the pole strength of the magnet.
Yeah, strength of it towards the poles. Either not just attracting, it can be repelling also. Attract or repel. Because poles can be attractive as well as repulsive, both. It has both type of force. It is attractive or repulsive to the another pole. But attractive to only some substance. So it has like two types of properties. Like one is attractive repulsive for any pole, or just attractive for any material. So pole strength SI unit will be ampere meter, strength of the pole. And this is a scalar quantity. Then ampere strength meter means M0, L1, T0, A1. This will be the dimension. So then let's discuss magnetic moment. That is dipole moment. So have you heard this magnetic dipole moment?
No, sir.
Okay, fine. So magnetic, like see, moment, if you remember, it's like position.
Yeah, sir.
Okay, so magnetic moment, same way, same way how we say in English, like normal movement, similar way. Now suppose if we take
So we can
like
say we can say the moment or dipole caused due to magnetic force.
yeah, that's it. So that is distance and into force. Here force is magnetic force. So magnetic strength into 2L. 2L is your, what is 2L? It's not 2 into L, it's 2L. What is 2L?
The
Length of
length.
dipole. Yeah. So this, if you want to remember, just make a note of it. Length of dipole. And this is strength of the dipole. Actually, we got here standard formula, M equals to M into 2L. So unit you can find out. What is the unit? Ampere. So unit of M was ampere meter. So again here meter. So ampere meter square.
Square.
So dimension will be M0 L
2 I1.
2 Yes. Or A1 T0. Now let's write some properties of magnet, like our Kim points. So you can say as a Kim points. Keep in memory. Now the first one, let's write about bar magnet. Now if I cut a bar magnet into this equal portion, suppose I'm cutting into this much portion. So it will be divided into m by n part. Okay. So when like bar magnet cut into n times of portion, so then pole strength of each, this is your pole strength, will be divided as m by n. But here it is, one thing is remains same for all, that is 2L. Next, if bar magnet is divided into like this, or let's say n equal perpendicular, and this is a parallel cut, north south, north south, perpendicular cut, then 2L will be divided into L parts. Here m is constant, so your magnetic movement will be m into 2L by n. Here magnetic movement will be m into 2L cross m by n. So that's the difference here. So m dash, here m dash equals to m by n. This m dash again m by n. So in both case we are getting as m by n value. If you see, I'll make note of it.
Yes, sir. Sir, can you scroll down once?
Oh, down this one.
Yeah, sir.
Done.
Yes, sir.
Hello. Then what if both? What if we combine both? Then suppose third one. Let's take one. This magnet, it's dividing into n equal parts in vertical as well as horizontal manner. So let's take horizontal x manner vertical y manner. So here m by x as well as 2l by y. So m dash will be what? M 2l by x and y. So in short, what are we like making conclusion out of all this drama? What conclusion we can make? Tell me. All this drama, what we wrote, out of that, what conclusion we have to make, or we will make this? Tell me. You're listening? I can't hear you. Can you hear me? Am I audible? Okay. Okay, let's go for next. Now, if we divide this bar magnet into like some portion, so north and south. So this, like if we connect like this will be acting like that. So suppose this will be north and this will be south, and this will behave as a north and this will behave as a south. This will behave as a north and this will behave as a south. So this all connection will have. So means each portion will have as a bar magnet. So this is what movement. Are you there or not there? Because I cannot hear you. I guess you can hear me, right? Can you hear me? So if we add some characteristics like this, so they always form closed curve. Out of all this, let's conclude some few points. So magnetic force or magnetic line of force, let's say, line of force are in closed curve. So if I draw like this, So this are closed. South. So from north, it's moved, emerge out. South, it merge in. So magnet line of force are in closed curve. So outside the magnet, it goes out. So it from north, it goes outside. If you are observing this diagram, see from north, it's moving outward. In south, it's moving inward. Inward, not moving outward. So second one, we can say something like that. All in these corners, or let's say poles, its strength is always higher as compared to another place. And more this magnetic field lines, more the strength. So when we bring two magnets nearby like this, north and south, so north goes outward, south goes inward. If I bring one more magnet, which is north and south, so this goes outward. So if it goes outward, then only it can get attracted because it will get inward. Now, suppose if I place one magnet which is north and south, and the south goes inward, and this is also south and north, this will also go inward. So this will have repulsive force. This will have attractive force. Repulsive force and attractive force.
Can you hear me now?
Yes, I can hear you now. What happened? You were not able to speak
Yeah, there
before?
was a power cut at my house.
Oh,
No,
were you
there
able
was
to
a
hear
power
me?
cut at my house, so I couldn't. Yes, sir.
Oh, okay. So likewise, as I said, so north-south will have attractive force because of this direction of magnetic field lines. Okay, so let's go for next thing. Magnetic induction or induction strength. So when we talk about magnetic induction, so this is all about just magnetic field strength, which is at point. Okay, at just we are talking about point. On that, whatever force experienced by the either north pole or south pole. Okay, so we can say force experienced by north pole at that point. So magnetic field B equals to force by M. So F equals to MB. If you remember in electrostatics, we had F equals to QE. And E was, what was E there? was E there? F equals to QE. What was E there? Your voice is like robotic. I don't know, but so this is E was electric field. If you say electric field, then it's right. I didn't hear because your voice became robotic.
There's a power cut, so yeah.
Okay, no problem. But I was hearing like, oh, so, something like that. Yeah. Fine. Whatever. So what I'm trying to say here, these both are same actually. Here we have magnetic strength. There it was electric field strength. Yeah, magnetic field strength, electric field strength. So F equals to QE, here F equals to MB. That's it. So unit of this one will be Newton per ampere meter or joules per ampere meter square or Vs by meter square. All the same only. So or Webers by meter square or finally Tesla. We will use T almost everywhere. But we should know all this conversion. I guess you know because Newton and joules we can convert. From there we can get voltage also. All that we know. It's nothing new. Okay, 1 second please. Somebody's calling. Yes, bache. Done? You wrote, I think so, right?
Yes, sir.
Okay. This conversion you have to remember, okay? Remember this conversion, all the conversion. Then if I want dimension, then what will I get dimensions? How to get dimensions now? Tell me fast. F by M means M1, L1, T minus 2, M was AL, right? So L will get
Yeah, sir.
cancelled. So M1, A minus 1, T minus 2. Am I right? What I'm saying here, M1, L1, T minus 2 by AL1, so which is LL cancel, so M1,
M1 L0 T power minus 3 A inverse.
yeah, T minus 2, not 3. Because it's Newton is always like meter square.
Okay, yeah.
So generally, what we wrote here, according to that, we can say whenever like some external field is there, all the north pole will experience something like and south pole. They both will be opposite in nature. That's what it means. So force towards this side for north pole will be MB against MB. Force will be this one. So this is obvious common thing. Both will have equal and opposite forces. Okay. So any doubt in this one?
No, sir.
Okay. Okay, fine. Like what I'm saying, like we'll wind up this one today, and we'll have it class tomorrow also, because I've got some work now.
Okay, sure.
Yeah. Bye bye.
Yeah, sure. Thank you.
Yeah. Yeah.